As I was telling the students last week, Tal, when I first did the physics course, this was my least favourite, worst question. I hated it. And now, it's my most favourite question. I think it's the best question in the exam. Because I feel like it's straightforward. That there's nothing... Once you get basic rules about, like we're talking about the battery, if it's plus or minus, and resistor, there's a couple of basic things to remember. What happens? Are some of the equations the same?
Yeah, and some of them they can't connect to each other because
Oh, well, don't worry. The biggest thing I'd be worried about is if two of the equations were identical. Are any of them identical?
No.
No, but then it is solvable. It just might be difficult, which is what I'll do now. I would like to finish electricity this week, and I should. And you notice I'm giving loads of time to circuits because they're simply the most important topic in this chapter for the exam, without a doubt. If you can do your circuit questions, you'd probably get 20 out of 20, okay, in that question in the exam. There's no reason not to get 20 out of 20 once you take care. Right, if you're still working on it, continue to do that. I'm just going to redraw it on the screen up here.
In the different form or seven.
Sorry, say that again, Tom?
In the different form or seven.
I'm doing this one you're working on now. I'm just going to solve it for you. This is what I was trying to draw earlier. No. Little neater. That's what I meant to draw earlier. So I hope this helps resolve the junction issue on the left and right a little bit better. This circuit on the board, what I've done is I've removed that J and J on the board, and I just drew it all coming together at a single point. Okay, so let me add in, what did we say? This one here is I1, and then this one here is I2. And then up here, I called this one here I3. And then down here, I called this one here I4. And then this is... where I can't see. Which one is this? 20... Sorry, which one is... 6, 5, 10, 6. So this is 6 ohms, 5 ohms, 10 ohms, 6 ohms, and then this one here is a 6 volt, and then this one here is a 4.5 volt. Okay, so our first one to do was the junction one here. So I2 and I1 are going in, and I3 and I4 are coming out. Take the loop on the top, and you get 6 minus 10I1 minus 6I3 equals 0. And then that's the loop at the top. The loop at the bottom. Now, I'll give you some advice. Whenever you have two batteries in a loop, you should start with the bigger battery. So starting with the 6, I have 6 minus 10I1 plus 5I2 minus 4.5 equals 0. And then lastly, the loop at the bottom, starting, well, only with 4.5. 4.5 minus 5I2 minus 6I4 equals 0. One junction, 3 loops, 3 small loops. Just to make this a little bit easier to write, I'll just, instead of using I1, 2, 3, 4, I'll use W, X, Y, and Z. So my first equation is W plus X minus Y minus Z equals 0. My second equation would be 10X, sorry, wrong, 10W, WXY plus 6Y equals 6, because I'm saying W1 is X, is W, I1 is W, I2 is X, I3 is Y, I4 is Z. Okay, the third equation would be 10W minus 5X. What I've done is I've taken them to the right, I keep this on the left, 1.5. And then my last one would be 5X plus 6Z equals 4.5. Now, if I divide this one by 2 to make it a bit... Well, no, actually, I'll leave it, because they're both 10. So these are the 4 equations you should have. Something like that. You match them up the same? Yep. So before I solve them, I'm going to get the computer to solve them. Make sure that it matches the answer at the back. Yep.
Can we leave it without X's, W's, Z's?
Oh no, I'm just doing that because I know from past experience it's easy for me to slip write an I1 when I need an I2 or something. Whereas if I have W, X, Y, Z, it'd be more difficult to make that mistake. Okay, did you write those 4 equations down with W, X, Y, and Z in them? Because I need to type them in, so I need you to read them to me.
Okay, then.
Yeah?
No way.
Yep, okay. So, what's my first equation? W plus X, is it?
So you have plus X minus Y
Equals 0. Okay, second equation?
10W plus 6Y equals 6.
10W plus 6Y equals 6. Next?
Yeah.
Yep.
10W minus 5X equals 1.5.
And lastly?
5X plus 6Z equals 4.5.
Okay, let's see what we get. Please be right. This is Kirchhoff number 23. Oh, well, they're only looking for one of the currents, aren't they?
Yeah. Current and voltage.
We're looking for
The I3,
We're
isn't
looking
it?
for Y.
We're looking for Y. Y is 0.39. What's the answer at the back?
3.29.
What is it?
3.99.
Yeah.
It's right?
Yes.
Booyah. Alright. And the voltage now we have to get. Sorry, which chapter number is this when you're looking at the answers at the back?
It's chapter
28, number 25. Okay, so I'll show you how to solve these, but I just wanted to make sure the answer will be right. But we still need to get the voltage next. So if you look at the diagram there, well, I'll go back to my diagram here. Zoom in. Whoops. Okay, which voltage do they want? They want the one that goes from I1 and I2. So from here to here, they set up the voltmeter. Which way is the current going? For example, if here the current's going left, but in this diagram the current's also going left. But I wonder if it was negative in my answer. No, they're all positive, aren't they? So that means I was right in the direction I drew my arrows here. So I want the voltage from here to here. Now, let me see. Yes, if I take, for example, this loop here, the voltage from here to here does not include these batteries here. Okay, so if we try to imagine this, if we use Kirchhoff's rule, when I start here, what's my voltage? 6. Then when I hit this one, I lose voltage. Lost. Then when I hit this one, I lose voltage. Then when I get here, gain. Lose as well. And then when I get to the end, it's 0. So I put the voltmeter here and here. It's like asking what are the voltages in these two resistors here. So we just use Ohm's law, V equals I or and V equals I or. And what's nice is we have the I1 and the I2. So can you tell me what the two voltages here are, please?
Can you come back to us?
The answers, yeah. So it's there.
The first is 4.2.
Yeah, it's 4.26 multiplied by 10, and the other one we multiply by 5. So the first one here is 4, I'll do it in black here, 4.26, and then this voltage in this resistor, yeah, it's I2, so that's the X times 5, isn't it? Yeah, times 5. So this is about, isn't it? Sorry, this is I2.
Oh yeah, the first one is right.
Oh, it's not? Okay. What do we get?
Go back to the 3.634.
The first one? Okay. 3.63. And then the second one, 5 multiply I2. So that's
2 is X.
is
So
X, yeah.
2.13.
2.13. Okay. Here we start off with 6, but we don't count it from there. So it's 3.63. I think I should subtract these to get the answer at the back, because this one loses voltage, but then this one gains voltage because the current's going the other way through the resistor.
What if it would go the same way? What if the
Then
battery would be?
if this was the other way around, yeah, then you would just add them together. The voltmeter is basically telling us the voltage in these two, because it starts here as the A and then finishes here as the B. So it's the voltage in these two. But because the current is opposite in the second resistor, I should subtract them. And what do I get as the total then?
1.5.
1.5, and the answer at the back? 1.5. Yeah?
Yeah.
I like this question.
You could have just done 6 minus 4.5.
Yeah, and that's the other one as well, which I'm going to say, because the total should be 0.
So were we able to just subtract 6 from 4.5?
Yeah. Although, I would think in most situations in the exam, that wouldn't happen so nicely.
So is
Yeah.
I1 is 1.3 ampere?
I1,
Yes.
I don't know, I have to get it back up. It's 0.36. I read it, yeah, sorry, because it's alphabetical. Is it? Oh no, it's not. They didn't put it in alphabetical order.
So you said in order.
Yeah, sorry, I was saying that the total on the loop should be 0 voltage.
No, I mean
Okay.
you said that on the exam we will have
Oh.
to use it or not.
In the exam, if you could take this shortcut, you should, but I'm saying I think the question will be made in such a way that you can't, that it wouldn't arise. Yeah. The reason for that working, Joshua, is because the voltage on the left should equal the voltage on the right of the loop, because the total needs to be 0. The voltage on the right, if I go from B to A, do I gain or lose voltage here? Well, if I'm going backwards through it, I lose it, and then this one here, I'm going through it, so I gain it. So the difference here is also 1.5. And it's not an accident that they're the same, because this one and this one should equal. They just should be opposite, a positive and a negative. Anyway, that's more. If you did see that shortcut, great. And you can't take it in the exam. But if not, don't worry. I much prefer just using Ohm's law here.
So can we take time on the IT?
Ah yes, now time the tricky part, the solution. Okay, so how do we solve this big system, like in the exam? So,
Who says I on the IT?
yeah, well, here these have W's in them.
That's much easier.
If I put these together, what would I be left with? An X and a Y. And then this one copies over as X, as W, X, Y, Z. And then this one copies over as X, Z. So, let's imagine I got the answers. Which should I put into which? What do you think? Well,
The second one,
We have
the
to
third
rearrange.
one, and then third one, first one.
there's a problem here because I've gotten rid of the W in the middle one, but the W has come back in the top one. So my mistake, or not my mistake, what I should do is put these together and get rid of W, so it's just X, Y, Z. Then put these together, get rid of W, so it's just X, Y, Z, and carry this one over.
How
So
do you get rid of W?
here multiply by 10 and subtract.
Okay.
Yep. Here's X, Y, Z, here's X, Y, Z. Put these together, get rid of X, so you have Y and Z. Sorry, not get rid of X. Get rid of Y, so you have X and Z. This one carries over as X and Z. And then put these together and get rid of, well, then just solve the two. And as you said, Tal, how do you get rid of it in the first one? Well, just multiply it by 10. 10, 10, well, I'll rewrite it. Okay, so it's, oops, 10x, is it x, was it x plus y? No, it was 10w, wasn't it?
Then that will-
Plus 10x minus 10y minus 10z equals 0.
So what if I change x, y, z in terms of W next time we do the first equation?
The order is not important, whichever you find easiest. For me, this looked like the easiest path. So if I subtract these, I get rid of w. And if I subtract these, I get rid of w, and then I carry this one. So let's do step 1. Step 1, they subtract, it's gone. Is there any x's here? No. Minus 10y minus 6y minus 16y minus 10z, no z's, minus 10z. 0 minus 6 minus 6. Then I subtract these. 10w minus 10w is gone.
6y.
6, well, there's no x's, minus 5x's, 5x. 6y minus no y's, 6y's. 6 minus 1.5, 4.5. And then I said carry that one. 5x plus 6z equals 4.5. Okay, now step 2, I should get rid of y. So I need to clean this up a little bit before I can do that. What do you think would be easiest if I... Well, if we have our calculator, we can just be
You
lazy.
can divide everything by 2.
In the first one, that would make it 8 and 6, and then get it to
But then
48.
you will be able to get rid of x first.
Yeah, but I need to keep in mind that I want x and z left in the first 2, because that's what I have in the third one. I'm trying to get rid of y. I need to get rid of y.
What if you will get rid of z in between the second and third one? Get rid of
Oh,
x.
as a different way to do it, get rid of the z's.
Not z's. Z's or x's?
Either. Originally, I planned for getting rid of the y. You can also get rid of the z. Or you could get rid of the x actually as well, but that would take a little extra. You could multiply these by 2 to make 10s and subtract them. Okay? If you want, you can do that.
Just subtract those 2 without multiplying the last 2.
Yeah, but that would leave me with x, y, z again. I don't really have much of a choice. I'll just stick with the original plan and I'll get rid of y. So, multiply, and keep the same, wasn't it? Yeah. If I want to cancel the y's, what should I put here? I think 3 would make 48, wouldn't it? And then here, 8 would make 48. Yeah. Okay, so I get 30x minus 48y minus 30z equals minus 18. And then here, 40x minus 48y. What's 8 times 4.5, please? 16, 32, and 48?
No, 36.
8 times 4.5?
36.
36. And then I subtract these, and I'm left with minus 10, yeah, x and z, minus 10x, gone, no z's, and then 36, 46, 54.
Yeah.
So you're right, there's one with x and z in it. And don't forget, I still have this one, which what I'm doing is solving the two together for the last step, step 3. Okay. Can I cancel here? Oh, I can multiply this one by 2. So for step 3 now, if I multiply this by 2, I get 10x plus 12z equals 9. Okay, so now on to step 3. Now I subtract, or sorry, add. What's that one? 18 z minus 18z equals minus 45. So z equals
2.5.
2.5.
Yeah.
And what was my answer?
Different with 0 point blah blah blah.
Dang. There's a number mistake somewhere. Oh well. Wait. So somewhere in my calculations of adding, subtracting and multiplying, I made a mistake. because I didn't get the answer on my computer program or the answer to the back.
So I did the same way, but I got access.
Yeah. So at what point did I write down a wrong number? Somewhere, yes. So I could go back through it and check where I make the mistake. But I think it would be much better use of our time if we go to another circuit.
Did you W?
Well, can I just check? Who was able to solve the equations without making any mistake? Good, okay.
I'm not sure if it's a mistake on the test.
Did you get the answers?
No, I got 1.35.
No.
Did you get the right answer?
Who solved the equations getting the right answer without making a mistake? And did you put them together in the same way I did? Or did you eliminate them in a different order? A substitution, yeah. But did you do it in the same order? Like get rid of W, substitute W, then substitute Y, and then you're left with X and Z? Yeah. So, I don't know. I'll let you figure out the mistake as homework. Because it'd be much better if I go on to another one. Okay, was that the only one you found difficult? Yeah. But there were a couple of other ones. 27, a couple of people, yeah. Anything else?
29, I think it's interesting.
You think you can? But 27 for sure.
Yes.
Yeah. Now what's the problem with 27? Is it like this one in that there's lots of equations? Yes. 27. Oh. At first it doesn't look so bad. Let's see what happens. Alright. So we've got this here. There's one in the middle here. One in the middle here. Battery here. And then connected here. So this one here, we don't know. We know that this is twice as big. We know that this is an OR. This is a 2 OR. This is a 4 OR. And this is a 3 OR. Oh, and they tell you what OR and E are. So in the answer at the end, we can just sub in OR and E. Determine the direction and magnitude. Okay, so in other words, solve it. Right. So we'll start with the bigger battery. That's I1. And to here is I1. But then it splits here. And this one here is I2.
So you forgot to label something.
Did I?
A and E at the bottom.
A and E? They're just points. We don't need those. This one here is I2. And then here they split, connect, split, connect. So I'll call this one I3 and this one I4. And then this one here is I2 and this one here is I1 and this one here is I4. This one here is I3. And by my same logic as in the previous question, this big connection here, I can just make it as one junction. Okay? So if you wanted to, you could have drawn it like this. Can you use your imagination? You all have imagination, don't you? Remove this wire and then connect these two together. You can just make it like one junction. Okay? So you don't need an I5 for the bottom. And if you want to picture it, that's what it would look like here. Okay. Right, junction rule. But if I use the junction rule here, I get the same equation as up here. So I don't need to put them together. My first equation, I1 plus I2 minus I3 minus I4 equals 0.
So where do you get that?
Where do I get what?
From which point did you recover?
You have a meeting with Sylvia?
Yeah.
Okay. At this exact time?
Yeah. No,
What time?
Actually, I'm going to go print something out that she told me to. So, yeah.
Why didn't you do this before class?
Because she told me today this morning.
Alright, I'm going to check with Sylvia later. I hope your
Okay.
story checks out. You asking me, Tanish? I got it from looking at the junction
Oh,
at the top. Okay, next is the loop. Joshua, show some respect, please. Thank you. Next is the loop. Which loop should I take first? What do you think? Why don't I take this triangle loop here on the right? So I have 2e minus 2 or I1 minus I4 3 or equals 0. Okay. Then here, next loop, E minus I2 or minus 4I3 or equals 0. Okay? And lastly, what loop to take next? What about this loop that goes up here, across, down,
yeah.
the outer loop?
That's
The outer loop, yeah, okay. So we have 2e minus 2i1 or plus or I2 or I2, it doesn't matter here. Plus or minus for the battery?
Plus.
No.
Oh no, minus.
Minus. Equals 0. Because there's no change in voltage at the bottom. There's no resistors or anything. Okay, so, yeah.
I mean, change the I1, I2, 3, 4, whatever.
Yep. This time, I'm not going to make any mistakes solving it. Okay. Here, W plus X minus Y minus Z equals 0. Maybe I should put in the numbers now. Oh, maybe not. They look ugly. Alright, here.
No, you can put the R. It's just
I'll leave.
1 kilo.
So 1,000.
10 to the power of 8.
Yeah. Alright, I'll put it in. Okay, so here we have 2,000 W plus 3,000 Z equals 500. Well, that's nice because that will all cancel down. Isn't that right?
No, what is it?
Oh yeah, it's right.
Now, don't freak me out. Is that right or wrong?
It is right.
It's right?
Yes.
Okay. Don't freak me out, man. Don't freak me out. Now the next one is 1,000 I2, which is X, plus 4,000 I3, which is Y. W, X, Y, yeah. Equals 250. And then the last one is 2,000 W plus 1,000 X equals... Oh, sorry, no, I've got a sign mistake here. Let's be careful. That's a minus there. That's a minus there. That's a plus. And it'll be 2E minus E, minus 250 here. Is that right? Now please check.
Yes.
Now look up there.
Yes, yes, correct.
Alright, so just w plus x minus y minus z equals 0. Divide by 500 and I get 4w plus 6z equals 1. And here I get x, no, sorry, 2x plus 8y. No, I can't divide by 500 there. I can divide by 250. So I get 4x plus 16y equals 1. And then divide by 250 and minus it. 8w minus 4x equals 1. Okay, so there are my 4 equations. What to put together? Well, let's see. I've got x and y, w and x, w and z, w, x, y, and z. So, let's see. I could, if we use the substitution method, I could take the x here and put it into that one, and then put it into that one. And I'd be left with w, y, and z.
Why not?
If someone has another idea, I'd like to hear. Yes?
What if we start with equating to each other first and fourth one?
Actually, you know what? Here, I can get rid of w's, and I'll be left with x, y, z. So let's get rid of the w's, okay? I should multiply this by 4, so this is 4, 4, 4, and 4. Alright, minus, they're gone. 4x minus no x is 4x. Minus 4y minus no y is minus 4y. Minus 4z minus 6z minus 10z, 10. 0 minus 1, minus 1. And then this continues and this continues. 4x plus 16y equals 1, and then 8w minus 4x equals 1. Okay. And what should we get rid of next? Oh wait, I'm missing an equation. Sorry, this one here. I'll put it down the bottom now. 4w plus 6z equals 1. X, 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 w, w.
We don't have the last one.
Ah, there's w here. Sorry, now I need to... Stephen, no happy. Now, if I... son of a... Right. Start again. Right. Focus, Stephen. Focus. I didn't realise I had W in the last one as well, so I want to get rid of the W in that one too. Yes? I know what to do. So unless you have a super idea...
We have to get rid of...
I'm getting rid of the W because I'm stubborn.
Of y's, because we have y's on the two equations.
We have Y only in 2.
And all the others are in 3.
Great, okay, let's do the Y's. 16x plus 16w 16w plus 16x minus 16y minus 16z equals 0. 4w plus 6z equals 0. 4x plus 16y equals 1. 8w minus 4x equals 1. I multiply the first one by 16 because now you can see the first one and the third one are the same. Yes?
You can add them.
So add them together. So adding the first and the third, 16w and no w's is 16w. 16x and 4x, 20x. Minus 16y and 16y, it's gone. 0 and 1.
16Z.
Oh, minus 16Z, thank you, Mo. And 0 and 1 is 1. What? No, don't talk. What is it? What's wrong, Joshua?
I was just asking what W was.
Okay, no, wait. Please, really, I do not need distractions right now, okay? Think of this as open heart surgery, okay? I don't want to be distracted. So I've done the first and the third, and the second is the same, and the last one is the same. Okay. Now, what should I get rid of next? Maybe the W's? Yeah, the W's. So I'll multiply this by 4 and multiply this by 2. So I have 16W plus 20x minus 16z equals 1. 16W plus 24z equals 0. And then 16W minus 8x equals 2. Right. Now, subtract these. 16 and 16 is gone. 20x minus no x is 20x. Minus 16z minus 24z is minus 40z equals 1. Subtract these. They go, what's that one? 30. No, they don't go together. So you have 24z plus 8x equals minus 2. Yeah. Right, getting there. Now, what should I do with these? Cancel them. If I want to, I can divide this by 2. 20x minus 40z equals 1. 4x plus 12z equals minus 1. Okay. Multiply this by 5. 20x minus 40z equals 1. 20x plus 60z equals minus 5. Subtracting them, minus 100z equals 6.
6 over 6.
Z equals minus 0.06. Yeah? 6 over 100 is that, isn't it?
Yeah.
Alright, do we need Z? Do they ask for all the currents?
I thought you said it was easy.
Still my favourite question. Still my favourite question. I don't think I ever said it was easy, or maybe I did. Alright, still easy. I want the current from A to E. What current is that? That's the one that's leaving. Well,
That's the one that we didn't name.
yeah, but we can work it out from working out the other ones.
Which one?
Well, the other ones.
We found I4,
We found I4, which is which one on my diagram?
which is the one from C to E.
Yeah, it's fine. We can work out A to E, because if we know the other currents,
So we need
we can know what's going into that junction and what's coming out of it to get the total. So we need the two going down and the other two. If I go back here, whoops. You see here I2 and I3. And then I4 and I1. Yeah. If I work out each of these, I can know what's happening in this piece.
Isn't that just
Well, what I can do is
Is it I3 plus I4 equals I1 plus I2? Is it like that?
not quite here, because they don't want you to.
Two are going in.
Yeah. This one is like it's the in and this one's like the out. So what we can do is we can subtract these because they're different.
Okay.
We can subtract these because they're different, and then we can subtract the two answers to get that one. Yeah. Now I don't know if this is right, so I'm going to use my computer program. Can you call out the?
No,
No, I want it. Give me these 4 equations, please. No, but the answer at the back is not what I have done so far. So I want to know if I'm right so far. So can you read out the 4 equations, please? Did you write it down?
W plus X minus Y minus
W plus X minus Y minus Z equals
0.
0.
For
You can give me the, 4W.
4W plus 6Z equals 1. 4X plus 16Y equals 1. 8W minus 4X equals 1. Inshallah.
God willing indeed. Right, 1, 2, 3, 4. No! Oh wait!
Yeah. Yes.
Yeah!
But we found it with
So
different
check the
signs,
answer.
and we have Z equals to 0.08.
Oh, wait.
0.06.
Oh.
No.
Wait, did you use the same letters that I did in mine when you called them out? Are you sure? Yes?
I got that.
Is it the same as that? Yes? Alright, you can talk to Tanish after class. Did you get the same? What did I get? I got the Z, was it?
You get Z equals minus 0.06.
Teacher said.
It's good. It's not even naked.
Tanish, what's the question?
No, she's asking me.
No, it's not when I'm talking, and especially not when I'm thinking.
I'm sorry.
Joshua. Carl.
I really don't understand.
No, but then that means you should be focused and not playing with your phone. The difficulty here is there is, again, I was distracted. Please, you don't need to say anything right now, Tanish.
Okay, we'll give this one as a homework for you. You'll solve it.
That's a whole thing. I have no problem once I don't have
You
people
can
talking
solve
with
it.
me.
You didn't solve it, so you have
I
problem.
made a mistake somewhere. Someone distracted me at some point. I haven't. I'm half happy. All right. Which two letters are the ones going in on the left on the diagram?
I2 and I3.
I2 and I3, which are going to be
I2 is
X.
X
And
I3
I3
is Y.
The difference between them is 0.05.
Yes.
Right, and on the other side, what's coming out?
I4 and I1.
I4 and I1, which is W and Z. The difference there is 0.05. 0.05. So 0.05, and what's the other one? Is it? Oh, it is.
It's because we're using letters.
Yeah. Wait.
Clearly because we're using letters.
Okay, again. I2 and I3. I2 is X, I3 is Y.
0.05.
Yeah,
And on the other side?
it's the same.
4 and 1. It's W and Z.
Beautiful.
Oh, wait, we subtracted them, but if they're going the same direction, we could add them. So is the answer at the back 0.10? Is it 0?
Do we have to choose the
Ah! Yeah.
We don't
Sorry,
have-
it is 0.05. No, listen.
Yeah.
On the left, we got 0.05. On the right, we got 0.05. The answer is 0.05 because what we're saying is what's going in is 0.05. What's coming out is 0.05. They must be the same. In fact, I didn't need to get both sides. It was enough to get what was going in or to work out what was going out because they must match on the same wire. Remember, 1 coulomb goes in, 1 coulomb comes out. So it is 0.05, yes.
Did you solve it?
Sorry, could we do this over?
Did you do all this research?
I will do this again. Hey,
Did you make this?
wait. I'm going to solve this again. And I will kill anybody who talks or distracts me. Alright? Deadly serious. I'm doing this one again. And I want your calculators out so you can check as I'm multiplying. And I'm serious, Joshua, Tanish, you sometimes distract me. This is exactly the thing I'm talking about. What's wrong? Go. Right, are you ready to start it then? Yes. Now, before I start,
Maybe you can take a look on the first solution.
No,
it's
I would-
easier.
please, just don't distract me, okay? And just watch carefully. Alright. Now, before I start, most important thing to check is, do we have the 4 equations? This is them here. Here they are here. So, just take a minute. Are those the same ones that you have? They match up with what you have? Yes?
Yeah.
Yes? Those 4 equations?
No.
Yes? No?
Yeah, actually same.
They're the same.
I'm
Yeah.
not using different.
And this is what I typed into my computer program. X plus y, w plus x minus y minus z. 4w plus 6y equals 1. 4x plus 16y equals 1. 8w minus 4x equals 1. Right. Now, just read the equations back to me. I'll get them on a fresh page.
Maybe we start the
Right now.
for good luck.
What?
We start the computer for good luck.
Start the computer?
Restart.
Oh, we started. No. Right, give me the first equation.
2e.
The 4 equations I just had.
W plus x minus y minus z
W plus,
plus x
yes, minus y minus z equals 0. 0, yes? Right. What?
To be precise, w equals I1, x equals this, y equals this.
At the end I will. Next.
2000 W.
No. What I just had 10 seconds ago.
But what if we did a mistake there? What if we did a mistake in the very beginning?
That's possible, but I checked with her and the computer program gave the answers at the back, didn't it?
4x plus
16y equals
4x
1
plus
plus 16y
16y equals 1. Next.
4w plus 6z equals 1.
Equals 1. And then the last one.
8w minus 4x equals
8w minus 4x equals 1. This is why. Alright. Now, just watch. I'm going to use Gaussian elimination to solve it. Remember that method in maths class?
1. Yes.
Yeah. So if I put in a nice big fat block here, 1, 1, minus 1, minus 1, 0, 0, 4, 16, 0, 1, 4, 0, 0, 6, 1, and then here 8, minus 4, 0, 0, 1. What? This is easier. Now, does this one have an X in it? Yes. Does this one have a Y? Yes. Does this one have a Z? Sorry, W, yes. X, Y.
Yes.
Y here? No. And Z here? No. Does this one have a W? Yes. This one here have a X?
No.
No. So I need to rearrange them so that each one has what it should. So this one here, it can be on the top, it can be on any line. This one here can only be on the second or third. This one can be on the first and the last. I'll swap these two. So I have 1, 1, minus 1, minus 1, 0. 0, 4, 16, 0, 1. 8, minus 4, 0, 0, 1. 4, 0, 0, 6, 1. Okay.
So what's the point of doing that?
Yeah, what's the point of
To use the Gaussian method, you need to make sure that the first row has a W, the second row has an X, the third row has a Y, and the fourth row has a Z. So does this one have a W now? Yes. An X?
Yes.
Yes. A Y? No. A Z?
Yeah.
Yeah. So what happens if I swap these two? Would that be okay?
Yes.
Yeah. So I'll.
X and
So I got 1, 1, minus 1, minus 1, 0. 8, minus 4, 0, 0, 1. 0, 4, 16, 0, 1. 4, 0, 0, 6, 1. W,
Yes.
X,
Yes.
Y, Z. Okay. Now, do you remember what's the first thing you do? You get all of these numbers the same. So what would I multiply here? No, I want them all 8. So this should be 8, 1, don't need to do that, that's a 0. And then this one here, 2. Now, make sure I'm doing this okay. 8, 8, minus 8, minus 8, 0. 8, minus 4, 0, 0, 1. 0, 4, 16, 0, 1. 8, 0, 0, 12, 2. Now, I want to make these two 0. Okay? So I can do the first minus the second, and then the first minus the third. The fourth, sorry. So 8, 8, minus 8, minus 8, 0. They minus 0 here. No, 12 here. Minus 8, minus 8, minus 1. 0, 4, 16, 0, 1. And then here, 0, 8, 8, minus 8,
20.
minus 20. And here, minus 2. What's wrong? Now, I have all the zeros there. Now I need to make these two 0. So what should I multiply here and here?
2 and 1. Yeah, 104.
2 and 1. Stop talking. I'm really serious now. You need to focus. If you find it difficult, laughing's not going to help you. Now here, multiplying this by 2 and 1. 8, 8, minus 8, minus 8, 0. And then 0, 12, minus 8, minus 8, minus 1. And then here, 0, 8, 32, 0, 2. 0, 8, minus 8, minus 20, minus 2. Okay. Now, how do I put these together? With a subtraction as well. So just subtract like we did a moment ago. So I have 8, 8, minus 8, minus 8, 0. 0, 12, minus 8, minus 8, minus 1. 0, 8, 32, 0, 2. 0, 0, 0, 8, 8. 0, 0. Oh wait, I want... okay.
20.
I'm subtracting. Minus 20, and then here... Plus 20. Now there we go. This is where things go wrong. And then here... 4. Okay. I'd like to get rid of the 8 here. So I can put these two together. And then I just have to get rid of the 40. So what's the best way to get rid of the 8 and the 12 here? Yeah. This one by 2 will make 24, and then this one by 3 will make 24. So we'll do that one. 8, 8, minus 8, minus 8, 0. Here, 0, 24, minus 16, minus 16, minus 2. Here, 0, 24, 96, 0, 6, 0, 0, 40, 20, and 4. Okay. So if I subtract these together, look, this is relaxation, okay? 0, 24, minus 16, minus 16, minus 2. 0, 0. Right. Calculator.
Minus 1 and 2.
Minus 1, 1, 2.
Minus 16, minus 8. 0, 0, 40, 20, and 4.
What is it?
Are you sure it's
Yes, it is minus.
The last thing to finish is to get rid of these two.
Let's multiply 1 by 40 and another by 100.
And 12.
Why not? You have calculators, you can do it, okay? So we'll multiply this one by 40 and this one by 112. So we have. So while I'm writing the top, you can be working out the next lines.
Yeah,
0, 24, minus 16, minus 16, minus 2. 0, 0. First.
4, 4, 8, 0.
Next.
6, 4, 0. Minus
Six.
6, minus 6, 4,
And then this one at the end.
0. Minus 3, 2, 0.
Alright, and then this one here. 0, 0, 4, 4, 8, 0. Yeah. And then 2, 2, 4, 0. And then here.
4, 4, 8.
Alright. Now add the last two lines together. 8. Add because they're opposite signs. Alright, 0, 24, minus 16, minus 16, minus 2. 0, 0, minus 4, 4, 8, 0, minus 6, 4, 0, minus 3, 2, 0. 0, 0, 0. Alright, minus 640 plus 2, 2, 4, 0.
1600.
1600 exactly.
Yes.
And then here. 1, 2, 8. So if I rewrite the equations out, this last equation says 1600z equals 128. So what does z equal? 0.08.
Alright, chocolate.
I feel like I should get some reward now. Right, so that means then all the other ones are going to be the same. So now that we have the z, we can just sub it back in. If I put it into the third equation, what can I get? Y. And then into the one before that, x, y, z, and then finally into the top one, w.
Very recorded.
Huh?
Very recorded.
So recorded, yeah. I know the method seems very long, but
If you have like 40 extra minutes on the exam,
well, this is the thing. That question in the exam, you would have
20 marks.
no. It would be nearly
40, 50.
It would be 10
All of the exams.
10 marks, half a long question, 42 hours. You only have to do 3 questions in section B.
Yeah, you will have
And
three
if
and a half hours.
no, if 3 hours, 1.5. You would, you have about 30 minutes to do that in the exam.
Or we can figure out use her method.
Yeah, well that's what I do in the exam. But this method here is the one. You see, this method here is the one where it's least likely to make a mistake in when you have less concentration, because it's more mechanical. It's longer, but it's more mechanical. It's like a machine going through all the steps. Whereas with substitution and elimination, you have to do thinking. And thinking can be difficult when you're not focused. Or just it can be difficult for some people.
Do substitution. I didn't even.
You do whatever you like, okay? There's the answer there. By the way, it's still a good question in the exam, okay? What else is a problem from this? It was just those two? And hey, Joshua, was the difficulty with those two questions the solving of the equations?
What about direction?
The current direction.
We'll
of the
explain
current.
the current.
The direction of
No,
operation.
the direct-
Alright, now,
Direction.
I feel like we get very easily distracted. First, just answer my question, then I'll answer that question. So, was the difficulty with these two questions the solving of the equations?
Yes.
Yes. Writing the equations down to begin with,
Yeah.
there's no problem with it.
Yes.
That's good, okay? Because that would be half the marks. Okay? So if you only got halfway through the solution, then you would get 3/4 of the marks still. What's 75%? What's a grade? What grade is that?
Is 8.
A.
What's the next?
Okay? So I'm saying it's difficult to true. Stick with it. Stick with it until you what?
Well, what's A star?
Joshua, don't be greedy now. You remember your mid-semester result, don't you?
No, I didn't read. So.
What did you get?
Oh, you don't? You didn't get? Huh?
I didn't even read.
Yeah. So rather than thinking about A star as a goal, first maybe try to get to A level. Okay? Now, the absolute direction of the current, yes?
Yes.
I mean,
Yes, they did. They did ask for a direction. of
Which
the
one?
current.
Which one?
The one that we found from A to E.
Ah, okay.
We found the magnitude.
We found magnitude and then we need the direction. Okay. So, the current, were all my answers positive? They were, which means all my arrows are correctly drawn. Now, if you look at the one on the left, what two letters are going into the one on the left? What do we call it?
Up I2.
I2
down,
and,
down I3.
and
Down
down in, I2 out, and then
I3.
I3 in. How big is I3?
0.06.
0.06. And how big is I2?
0.01.
So the one going in on the left is bigger than the one going out on the left. So in total, is it going in or out on the left? In by 0.05. So if the current is going in on the left, I feel like it should be going from A to E. We can check that by seeing what happens on the right. So if I look at the right, what's going in?
1 hypo.
0.08. And what's going out?
0.1.
0.13. So in total, is it going in or out? Out by how much? 0.05. So it goes in on the left, 0.05, goes out on the right, 0.05. So clearly it's going from A to E. And what's the answer at the back? Which you had a 50-50 chance of getting right anyways.
80.
Which direction is the current? 80?
What if we done nothing and just guess it's like A to E?
Depends how many marks are gone for the question. Yeah. I want you to do another one of these. How far had you to go to? 20... No, 31, wasn't it?
No.
29. Ah, did anyone do 31? You did? Anyone else do 31?
I will pretend
Yeah.
like I didn't know.
Huh? Okay, pretend like you didn't know. I would just, either way, I'd like to know, who has 31 done? Yes? 2. Only 2? Yep. Everybody else do 31 now. Then I'll do it on the board. Sure will. Because I am hungry for lunch, and this is only going to be another barrier to solving this system.
Do you speak Irish?
A little bit. Enough to know if you're saying something bad to me.
Can you teach us something that
When I'm in a better mood.
you can write it in the comments for your YouTube videos?
Yeah, I have comments disabled. I thought it might be a
No,
wise
you
thing to
can
do.
write your-
Oh, I
just
can
give
add
me
it in.
the
Yes, okay,
description.
yes, yeah. Oh, yes, the description. All right, 31, please. Go try it. Okay, let's do it together, okay? Now, don't talk unless I ask you something, right, Joshua and Tal and Tanish? You're fine. You've been very quiet today, actually.
My mom is quiet.
Yes. Right. So let's start with the first battery, the 24 volts, and we'll take the top loop. So it's 24 minus 2I1 minus 4I1 minus 3I3 equals 0. Is that okay? 24 minus 2I1 minus 4I1 minus 3I3 equals 0. Let's take the second loop at 12. 12 plus 3I3 minus 1I2 minus 5I2 equals 0. Let's take the total outer loop starting at 20. 20 minus 2I1 minus 4I1 minus 1I2 minus 5I2. Now,
24.
24.
oh, thank you. 24. And where was I? Minus 5I2 plus or minus 12? What do you think? Plus 12 equals 0. And then the junction rule at the right, I1 minus I2 minus I3 equal 0. Now, I have too many equations there because there's only 3 unknowns, but I have 4 equations. So I only need to pick 3 of these to use. Let's pick the easiest 3. I should definitely pick this one. What else looks good? First one has I1 and I3, and the third one has I1 and I2. Yeah, so we'll pick those 3, yeah? So here on the top I get 6I1 plus 3I3 equals 24. And then here I get 6I1 plus 6I2 equals 36. And then the last one, I get I1 minus I2 minus I3 equals 0. Now, I can cancel here by 3. So here I get, dividing by 3, 2I1 plus I3 equals 8. 2I1 plus, I can divide by 6 in the second one. I1 plus I2 equals 6. And then I1 minus I2 minus I3 equals 0. Okay, I'll just cancel here the I1 if I want, or let's see, cancel I1, be left with 2 and 3. So let me just multiply this by 2.
Sorry, where can you get I1 plus I2 equals 6?
It's the second equation divided by 6. Is that okay? Can I scroll back to the right? Multiplying this by 2, I get 2, 2, and then here
Okay.
12. Okay. Minus, and then here I should multiply by 2. 2, 2, 2, and minus. Alright, so they're gone. I3, there's no I2s, so it's 2I2, minus 2I2 plus I3 equals minus 4. Minus I2, yeah, okay. And then here, minus again, so I get 4I2 plus I3 equals 12. minus again, minus 6i2 equals minus 16. So I2 is 16 over 6, which is 8 over 3, which is 2.67. Right or wrong? Okay.
2.5.
Hmm?
2.5.
The sorry, what is 16 divided by 6? I don't even know anymore.
2.67.
And what's the answer at the back?
2.5.
Okay, so it's just look carefully back at my steps. There's just one small thing. So did I add divided by 3, 2, 1 and 8, yes? Divide by 6 is 1, 1 and 6. Then multiply by 2 is 2, 2 and 12. Here 2, 2, 2. Okay. I subtract these. 2i1 minus 2i1 is gone. I2 minus 2i2. Then I3 and no I3. 8 minus 12 minus 4 looks good.
Are you sure that you can subtract first one from second and then subtract second from third?
I'm 100% sure.
Why? Why would you do that? Just look at that. Just you will be left with two equations.
I'm sorry, I see my mistake here. When I subtracted these, that should be 2i3. 2i1 minus 2i1 is gone. 2i2 minus 2i2 is 4i2. No i3 minus 2i3 is 2i3. Yeah. Now let me just get this fixed up here at the end. Subtract again, is it? No, I have to, if I want to cancel the i3s, I'm going to have to multiply this by 2. So now I get, no talking, minus 4i2 plus 2i3 equals minus 8. And then here, 4i2 plus 4i3 equals 24. Is that right? Multiply by 2, 4, 2, 8. Not multiplying this last one by anything. I'm keeping it the same. Plus 2i3 equals 12. Okay, then what do I do? Just add them together. So I get 4i3 equals 4. So then i3 equals 1. Is that the answer at the back? Alright. Now to get I2, I can put it in here. 4i2 plus 2 equals 12. So then I2 is 10 over 4. 2.5? Alright. I1 equals I2 plus I3. So I1 is 3.5, yeah?
How many equations did you get from the circuit?
4. I only needed 3, so I discarded any one of my choice.
You just used 3 equations as the loop, the junction.
I used a junction and 2 loops.
Okay.
See how much easier that is when everybody just cooperates. So if you look at that now, that's using elimination. Okay, so Gaussian is long, but it got to the answer. Elimination, I don't think some people like Tal, like what you said, and Joshua maybe as well. You don't like when I reuse the middle one twice for 2 subtractions, okay? But you are allowed to do that one. And some people prefer substitution. That's fine, okay? I just think for the exam, just do whatever one works best for you. Okay, whatever one works best for you. Joshua, you were shaking your head like you were unhappy with this.
It's just too long. So that's why it's too long.
Lunchtime.
This one wouldn't be
This one here, that would be near, like that would be, I'd say, 10 marks. 10 marks. Now, I just checked the phone there. I started this one at past, and it took 10 minutes to do. And it's 10 marks, so it's 10% of the exam in 10 minutes. How many marks in the exam? 100 marks. How many minutes? How many minutes?
3 hours.
3 hours. So that's
Exactly 3 hours.
exactly 3 hours. That's 180. Yeah, so this here, if it is 10 marks, it's 10% of the exam, so it should take how many minutes? 18.
What?
Hang on, just no, don't do the shutting down sound. How many marks in the exam? 100. How many minutes? 180 minutes.
18 minutes.
Thank you. Focus. So 10% of 180 minutes is 18. This is 10% of the exam, should take 18 minutes. It took 10, so this has gained you 8 minutes for another question. Okay? It's important, okay? Because some questions will take a long time to do and some won't, alright?
How many question would be going to be using this method?
It could be as little as 10 marks, but as much as 20 marks.
No, I mean how many questions?
It's usually a half a section B question, sometimes a full section B question. So it's at least half to a full section B question. Doesn't really show up in section A though. Ohm's law shows up in section A. No, there's no reason saying they wouldn't. They could. They just haven't. If they did put Kirchhoff in section A, it would be something that needs the loop rule once and the junction rule once to make it shorter. So you have just 2 unknowns. Yeah? I'll give you a couple to try for homework. Just 2 to do for homework, okay? So, let's go back to page 69. What one looks nice? Page 70. I like to look at 28. It actually looks pretty straightforward. There's no weirdness about it. How many loops? You can make 1, 2, 3, 4 loops there. Well, you can make 3 small loops and 1 junction. They would be like the ones in the book.
Yeah, those
Except maybe not quite as difficult as the 2 I did at the start. What was it, 25 and 27. But, you see that one there, 28. That's exactly like what you could get in the exam, except there's usually some resistors in it as well. So, do 28 as a warm-up, and let's see one with resistors in it. Um, 30. I will check 28 and 30 tomorrow. Now, please note there are no answers at the back for this. Okay? So what I'll do tomorrow is I'll write the equation on the board, I'll get the computer program to solve it so you can check your answers. Or this computer program is on Moodle to download if you want to use it on your computer too.
Is there an application that
Huh?
Is there an application?
There are programs on your phones that you can use to solve equations, system of equations, yeah. And there's a website. Does anyone know that website? What's it? Wolfram? Yeah. Are you the only one who knows that website?
Wolfram.
Maybe, I don't think they're quite ready for it yet. That's not sure. Yes, yeah. It's a website that is very useful. It's like my computer program for solving equations. Yeah, but you can't do it in the exam. You can't whip out your phone and go solve.
Can I take a look in my exam?
Huh?
My exam.
It's definitely going to have to be after lunch because I'm just too tired of going to see more
Okay,
students.
just tell me my grade.
You just want the result. Yeah.
If I will be happy with that, I will not ask to.
Here, I'll write it down for you, alright? So I remember it. I take it you don't want to see your paper.
That's worse than I thought.
Yes. You guys make me tired and hungry. I'm a little angry as well. I see you.
My sandwich.
No, it's okay. I've got lunch. I'll see you. Do we have cross legs today?
No,
Thank goodness. I'll see you tomorrow. Okay.